Hi everyone, here's the quiz video for week 5-1, so Monday's lecture. Implement an alphabetical sorting algorithm for the words coming from a string. Use part of weeks 4. So we need a string. We'll call it S, and we'll use the same words from the week 4 lecture, which is Sir, Maple, Érable, and Candy. Now, of course, this is a string, and we want to put each word into a different position of an array. So remember how we said that every time we see a space, we're going to increment the number of words we have by 1. But remember that the last word doesn't have a space at the end, therefore we need to start the number word count at 1. So number words is going to be the variable that keeps track of the amount of words we have. We're going to start it at 1. And now we also need a constructor. We also need a constructor, and we'll call this constructor words. What it is just a empty string. Okay. And now we're gonna say for int I equals 0, I less than s dot length. Of course, this is the length of a string, so we need the brackets. What we need to do here is we need to say that if you find a space at any character along the string, well, then what you need to do is increment the number of words by 1. Okay? Now that we have the number of words, we need to create a string array, an array of strings. We'll call that words array. And this is going to be a string of length, string of length number words. And yet again, we need another variable to keep track of the position at which we're looking at within this array. We'll call that one count words. And we'll set it at 0. We'll start looking at the position 0. Now, same thing as before, we're going to need a for loop. And this is going to build our words and put them in the array. So we have an if the s.car at position I is in fact a space, then what we need to do is take the word and put it into the words array at the position we're currently at, which is count words for the time being. It needs to be equal to the word. Okay. And what else we need to do is we also need to increment count words by 1 because we're no longer looking at the same position. But now if it's not a space, then we need to be building our word into our constructor, which is exactly what we're doing here. Okay, so this is taking all the positions at I and storing them at the next position in our words, and our words is just a string, and then once it hits a space, it'll put that word into the array at the next position. However, once we've put that word in there, we need to make sure that we reset our constructor to 0. So just putting it like that resets it to 0. Now do remember though that there is no space after the last word, so that last word is stored in our string word, but it's not being implemented in our array of strings. Therefore we're going to do that manually by saying words array at position count words, because we're still at the right positions. Those can carry on outside the loop because we initiated them outside the loop, the for loop also. And that's just going to be our word. Now what we can do is we can it's called words arrays. We can just print this and see what's happening. Yeah, there's enough right there. Oh, sorry, I put a semicolon there where it shouldn't be. Okay. Now it's not counter words, it's count words. That's not how you spell words, and the W is capitalized. And in nope. What did I print? Maybe I didn't print. 1 second. Okay, let's compile and run. There. So all our words are now currently stored in an array of strings, each one at a different position. Great. Now what we need to do, or the question asks us to do, is find a sorting algorithm to sort this alphabetically. And therefore we're going to use a different method for that. This is a method that's going to return an array of strings. And it's going to be called bubble sort. Okay, and this bubble sort needs to accept an array of strings as an argument also, and we'll call it A. Whatever. Maybe not. Maybe we'll call it words array, just to confuse us. Okay, now obviously we need to send this words array to our bubble sort. We can do that right now. We can just say words array is going to be equal to bubble sort when I give it words array also. So therefore this here is going to have to return by convention a array of string words array, and this words array that's being returned is going to store in our words array, so overriding our initial words array. Okay, and technically after that, if we print the words array, it's going to be sorted. But first let's take care of the sorting algorithm. For this sorting algorithm, we're going to need 2 for loops. One that's going to take care of the amount of times we go through this sorting algorithm. So this is going to be words array dot length I++. And the second for loop is going to be taking care of the positions within our words array. So this is the amount of times the sorting algorithm is going to go, and this is the position within our words array. Okay. Now, technically what this is going to do is this is going to, we're going to use this method called compare to. And what it does is that it looks at the value at the right, and it looks at the value, it looks at the value at the left and compares it to the value at the right. So this case we're looking at words. It's going to look at the word at the left and compare to the word at the right. And if the word at the left is alphabetically smaller than the word at the right, then it's going to return a number that's less than 0. And if it's bigger, meaning we need to swap them, it's going to return a number bigger than 0. So if I do words array at position J, and I compare it to the words array at position J plus 1, okay? And if I say that is greater than 0, meaning this position left, the word is greater than the position at the word on my right, I need to swap them. Therefore, we need to swap them. And we can make another method of swapping, or we can just write it in right here. We're going to use string A as our placeholder for the time being. And that's going to be words array at position J. Words array at position J is going to be equal to words array at position J plus 1. And that's also why we had to put a -1 there, because if we're looking at J plus 1 to not get an out-of-bound error, we have to -1 from the total position where J can go to. And then words array at position J plus 1 is going to be equal to our A. Boom. And now that should work. So technically, if we look at what I did here, if we look at what I did here, it's going to take this and it's going to go through it once, and it's going to say Sir érable. Let's change maple and Sir because that's not their order. And now Sir and érable. Let's change érable and Sir because that's not their order. And now Candy and Sir, let's change those two because that's not their order. So as you can see, clearly we went through the whole array once, but this still isn't sorted. Why? Because we need to go through this sorting algorithm 4 times. So the length of our array times. That's why we have an outer loop up there, and that's why we have an inner loop that controls the positions. That looks at this one and this one. So now it's going to take this one and it's going to do it again. Maple érable, let's switch. Candy, maple, let's switch. And then you have Sir Maple, that's fine. Still not good. Let's keep going. Candy, maple, let's switch. Maple érable, we're good. Maple Sir, we're good. Technically, because we switched and because they haven't gone 4 times, this is 1, 2, 3, it'll go through it one last time, but there won't be any switching this time because it's fine, but it still has to go through it one last time. So now that we have our array, I can compile. It should be sorted, and it is sorted. Perfect. Now what we need to do is go to question number 2 and ask someone to write a word and then do a linear search to see if that word is present. If it is, we'll return it true. If it's not, we'll return it false. Therefore, we need a new method, and this is going to be a method of type of Boolean. And this is going to ask if we're going to call it present. Or we'll call it word search. And what it needs to do is pretty much, it needs to receive as argument the the array of strings that we have. And it also needs to receive the word that that our user is going to input, and we'll call it user input. So in our main method, we'll come back to this in a second. In our main method now, we need to now ask our user to input a word, and we're going to do that. Make sure I change that to a star. Scanner, we'll call it sc is equal to new scanner, expanding the memory for it, and it's going to be of system.in. And this, now we're going to have a string called user input, and that's going to be sc.next. So casting this casting this input into a string. Yeah. And now we should be good. Now this should prompt the user to input a word, which is great. The problem is that, remember that when we compare two strings, the compare method of strings is case sensitive. So I can't really, my array is with capital at the first letter of every word. But what if my user decides to put only lowercase or only capital case, or decides to mix the cases? It's getting a bit complicated. Therefore, I'm going to want to transform everything into lowercase to make sure that my input words are lowercase. Everything is absolutely lowercase. So here, when how I'm going to do that, I'm just going to say my user input is going to be equal to the user input. So I'm not changing its input, dot to lowercase. So this is just going to make, however it is written, it's just going to make it lowercase. Now I also need to make my words in my array lowercase. So here, when I store them, when I'm storing my words, I want to store it in my array, but as a lowercase, okay? So that I can now compare lowercases with lowercases, and I'm not going to have a problem, okay? Now that we have everything lowercased, we need to send it to our word search. So we need to print the result of this word search, right? Which is either true or false, depending if the word is there. So we're going to print the result of word search when it takes in as argument words array and input user. There we go. And this is either going to return a false or a true. Now back to our word search method here. We need to initiate a boolean called present, so if it's there or not. And we're going to let it be false for the time being. And now we're going to check if the word is here. So we need to use a for loop to go through all the positions in our array. Because this word that we're checking, it needs to be checked with every word at the position, with every word within our array. So it needs to be checked with every position of our array, because there is only one word per position, okay? So now we're going to if statement this and say if the word, so if the user input, dots equals to, because we're doing strings here, or just equals, sorry. If it equals to the words array at position I, therefore what's going to happen, I'm obviously missing something there. Okay, so if the user input is equal to the words at a position I, well then I'm going to change my Boolean present. So my present is now going to be true. And if it's not, it's going to be false, but since I already initialized it as false, that's fine. At the end of this whole method, we need to return this Boolean, which is called present. And this Boolean, present, the value of this Boolean is going to be printed here since it's the return of that method. Okay, so let's compile. That's a WO, compile, input user. Of course. No, what's up? Words away. Oh, I wrote user input, sorry. Boolean does not have two B's. Sorry, guys. Okay, now that we finally compiled, let's run. We're going to type in a word. You see here how... Oh, we have a problem because the first word is not lowercase, because here, remember how the first word is being put down here on its own? We did it manually. We forgot to lowercase that one also. So let's just go ahead and do that. Let's save, compile, and let's run. Now everything's lowercase. Perfect. I can type a word. Let's type érable. True, meaning boom, it's present. Now let's do that again. Let's type Ella, for example. False, not present. Okay, so that's our word search, our linear word search. Now there's another way of searching, which is the next question. Implement a binary search to find a word. So binary, I remind you that binary search, pretty much what it does is that it looks at the middle and it checks your word with the word at the middle and sees if it needs to go to the right or to the left. Okay, so in order to do this, pretty much we're going to work from there. Sorry. We're going to use another method called... So it also, the prof wants us to return -1 if the word is not there, or return the position. So position or -1 is an integer, therefore our public static method has to be a method of integers, and we're going to call this binary search. Is that what it's called? Yeah, binary search. Okay, so we'll call it binary search, and this binary search needs to take in our string words array, and it also needs to take in the word that we're searching for. So string user input. It also needs to take in two more things. It needs to take in the position of our lowest integer, and it also needs to take in the position of our highest integer. Okay, and I'll explain that in a second. And that's because actually we're going to be redefining the low and our high every time. When we call this method, however, we also need to call it over here. We need to I'm just going to copy this. Sorry. We also need to call it, okay, so binary search. We also need to call it sending those numbers there. So our lowest is always going to be 0, and our highest is going to be the length of our array. So words array dot length. That's our highest, okay? We're going to send it those two, but then within our method, we can change them, okay? So I'm going to, in this method, declare an integer called mid. Okay, so that's going to be the middle of our 2, and pretty much the mid is obviously high plus low divided by 2. Okay, so our mid is going to be equal to the high plus the low divided by 2. Now let's just go put brackets over this. High plus low divided by 2. There we go. So that's the mid. What we need to do is we need to create a new integer, and this integer is going to compare the value of our word, is going to pair our word and our mid, okay? So this integer, we'll call it k for all we care. And this is going to do, what it's going to do is going to compare, so the words array at the position mid, and it's going to compare to the word, so the user input that we're searching for, and we're going to store that in this variable k. Now we said again, here we're comparing it with our mid, we're comparing our user input with our mid, therefore if our user input is smaller than our mid, this k will have a value greater than 1 or greater than 0, meaning our mid is greater than our user input. Now if the mid is smaller alphabetically than the user input, then this k will have a negative value, smaller than 0, okay? So we're going to go ahead and implement those conditions. If our k is greater than 0, okay, meaning that the mid is greater than the user input, therefore I'm going to be looking at between low and mid, right? Because I know that my mid is greater than my user input, therefore I don't need to look at everything that's left to my mid. Okay, so my mid is now, my high is now going to be my mid. Sorry, I'm going to explain that to you very quickly. And then we have an else if. Say the other condition where my user input is greater than my mid, therefore my low is now going to be my mid. Okay? Else, we're going to return mid. And if it's not in any of this, we're returning -1. Okay? Now, I also need all of this to keep happening as long as my high is greater than my low. At one point, my high can be less than my low if my word is not actually present, and I'll show you exactly how. But this needs to keep happening as long as my high is greater than my low. And we'll just, there. Okay, so otherwise it's returning -1 because the word isn't there. So if we look here, for example, so this is what I coded. Let's say I chose the word maple. Okay, so here is our word that we chose. Sorry. Well, right here, maple. Okay. Now remember that everything is now lowercase, right? So boom, 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 and boom. Now that everything is lowercase and we chose the word maple, what's going to happen is going to look our 0 and our length, which is 4. So 0 plus 4 is 4 divided by 2 is 2. Our mid is position 2. That's the middle. Okay? Now what we're going to do is we're going to compare maple to maple. Maple to maple, okay, has, compared to is the exact same word. Therefore, my k is not greater than 0, is not less than 0, it's actually equal to 0. Therefore, I'm returning my mid being 2. Now, let's say I take the word érable, for example. Okay? Érable, again, 0, 4, that's going to be divided by 2, that's 2. That's my middle position. Now I'm comparing érable to maple. Érable is smaller than maple alphabetically, therefore, since érable is smaller than maple, this value will be greater than 0 because mid is greater than my user input. Mid is greater than érable. Therefore, this value is greater than 0. I'm redefining my high as my mid. So now I am looking, okay, now that I've done this, obviously this will loop back around. My high is my mid now. So instead of my high being 4, my high is now 2, okay? My low is still 0, so now I'm looking between 0 and 2, okay? I'm looping back around 0 and 2. 2 is my high, and it's still greater than my low 0. Therefore, I can continue doing this loop here. And now I'm going to do 2 divided by 2 plus 0 is 2, divided by 2 is 1. Therefore, my mid is now érable. If my mid is érable, I'm going to be comparing my user input, so érable, with my mid érable, and that's going to give me a k of 0, and I'm going to return my mid, which is in this case 1. Okay? So I hope you guys get the point. Let's take a word that isn't there. We'll take my name, for example, okay? Ella. So we're going to start again. 4 plus 0 is 4 divided by 2 is 2, 2. We're going to compare Ella with maple. Maple is greater than Ella. Therefore, we're going to have a k greater than 0. And if we have a k greater than 0, our high is redefined as our mid. Therefore, our mid is now 2 and our high is now 2 and our low is 0. High of 2 is still greater than low of 0, therefore we can keep doing this. Let's do 2 plus 0 is 2 divided by 2 is 1, therefore my mid is now 1. If I compare Ella with érable, okay? So my mid is 1. If I compare my mid, so érable, with Ella, Ella is smaller than mid, therefore mid is greater than Ella. K is greater than 0. And now my high is now my mid, okay? So my high, which was 2, is now going to be redefined as my mid 1. So this is now my high because we established that Ella is under this. So I'm now looking at a high of 1 and a low of 0. High of 1, low of 0. High is still greater than low. I can keep going. I'm going to now do 1 plus 0 is 1 divided by 2 is 0.5. But because we're dealing with integers, that goes down to 0. So this is my mid. My mid is now my low. That's fine. I'm going to be comparing Ella with my mid. So my mid is Candy, and that is less than Ella, meaning Ella is greater than Candy. Therefore, I have a k that's going to be less than 0, and my low is now going to be my mid. My low, okay, my low, which was 0, is now my mid. My mid is, in fact, 0. And yeah, my mid is 0. And therefore, I reach the point where yeah. Is it? Yeah. Okay. And therefore, I reach the condition where this is no longer true. Okay, because well, first of all, it's no longer true because it's neither it's neither the position 0th word or it's neither the position 1th word, and there is no position 0.5 word. Therefore, I'm returning my -1. Okay, so returning -1 because the word isn't there. Let's compile this code. Let's run it. Let's say, for example, érable, as we said, true, it's present, and it's returning the position 1. Now let's run it again with the code Ella. False, it's not present, but it's not returning -1 because I forgot to do something, maybe. No, that should be fine. Oh, sorry. My low is going to be my mid plus 1. Okay? Why? Because in fact, my low, okay? So if it's not smaller than my low, therefore it's my low is now going to be my mid, so my 1 plus 1 in this case 2, because I'm redefining now pretty much what's going on is instead of looking from here to here, I'm saying this is my low, but this is also my high. So there is where I do not meet this condition anymore. But for arrays where I have an odd number, so say I have A, B, C, D, and E. Therefore, I have odd numbers. Of course, this is sorted, but whatever. So what's happening is where my Ella is. So where my Ella is between B and A, but it's not actually at B or at A. Therefore, my low is now going to be between B and B, but that doesn't make any sense, right? Or say between, my low is now between C, my Ella is now between my word. It makes no sense. My word is now between C and A, okay? So I checked it with my middle B, okay? And it's greater than my B. So now my low is going to be my B. My high is my C. Hasn't changed. But, okay, we already checked it with the word C. Okay, we're going to check it again with the word B. It's not going to work. But instead of re-putting my low as my B, I'm going to put my low as my B plus 1. So now I negate this condition, so this condition is now false, and I won't go through this, and I'm going to return -1 so that it understands that it can't be between two positions, that it has to be at a position or it's not there. I hope this helped you guys. I know it's a little bit confusing. This is a kind of recursion using a while loop. We can do this with recursion also. You know, same kind of method, and I'll let you guys figure that out, and I could post the code with the recursion loop also on it if you guys want. So good luck to all.